this is for vectors 2 tutorial, BMQ question 3. Alright, we need to check the relationship between the following lines and to state whether the lines are have a point of intersection or are they just skew lines. Okay, so let's look at question 1a. Okay, we are observing if the position vector, so I'm doing a BMQ 3a. We are observing if the position vector of the point of intersection they have any relationship. Okay, so the first line is equals to 6 minus lambda 4 and lambda, right? And the second line is a Cartesian equation, is x minus 5 over 2 equals to y over 2 minus 1 equals to negative z. Right, so if we were to rewrite this, let's try to rewrite both equation. In order for us to solve them easily, we need to find the point of intersection. Let's try to write it in the vector equation form. Right, so for my first equation, I'm going to write it as 6, 4, 0 very quickly, plus lambda negative 1, 0, 1. Okay, this is the vector equation for the first line. For the second line, right, over here we can also again try to rearrange here. Lambda equals to x minus 5 over 2, x equals to 2 lambda plus 5. Simply lambda equals to y over 2 minus 1, lambda plus 1 times 2 equals to y. Okay, so you can actually work out quite fast if after some experience. Okay, lambda equals to negative z, z equals to negative lambda equal to 3. And then from here you can quickly deduce that your next equation is actually 5 plus lambda 2, so 5 plus 2 lambda, y is equals to 2 plus 2 lambda. Okay, so 2 plus 2 lambda, z is just equal to negative lambda, so it's equal to negative 1. Right, so I just put 5 to 0 over here and plus. Okay, so instead of a lambda, maybe what we want to choose is we choose mu, since the lambda is really used in the first line. Then we just take away lambda here. Maybe instead of lambda we use mu, because we want two different parameters. Okay, so both of these, right, will refers to x and y, z. This is a vector equation. So if they actually have a point of intersection, it means that there's a particular points for which they are equal. It actually means that there are particular points for which this equation is equal to this equation. What do I mean by equal? So we know that R itself, right, represents x, y, z. Okay, and for the first line, R itself represents what? It represents R1. Let's say just R1. Okay, so 640 plus lambda negative 1, 0, 1. In the second equation, x, y, z, or R2, okay, represents 520 plus mu 2, 2, negative 1. Okay, so what does it mean? It means that you can see that for a particular, suppose if they intersect, right, there could be particular points for which this 6, drawing out the first one, right, the first entry, 6 minus lambda could be equals to 5 plus 2 mu. If I draw out the second entry, it means that there could be a particular y value where 4 plus 0, okay, so 0 lambda, okay, so actually just write it out. Okay, so this equals to 2 plus 2 mu. Okay, third entry, lambda 1, so lambda equals to 0 plus equals to negative mu. Alright, so very quickly what you can do is you can just now do a simultaneous equation. Lambda equals to negative mu. Let's say you sub it here, right, from equation 3, equation 2, and equation 1. Alright, from here if you sub it inside, you sub 3 into 2, you sub lambda equals to negative mu into, you have 4, 2 plus, in fact from 4 itself you can see 4 equals to, so sorry, let me just rewrite everything. You can see that actually from 2, right, so 4 equals to 2 plus 2 mu. 2 is equals to, subtract 2 on both sides, I have 2 equals to 2 mu, mu is just equals to 1. Alright, and from here, from 3, since lambda equals to negative mu, lambda is equals to negative 1. Alright, let's just check if for the last equation it does satisfy. 6 minus lambda from 1. 6 minus lambda is equals to 5 plus 2 mu. Now the left hand side, remember that lambda is equals to negative 1. So we have 6 minus negative 1, this is equals to 7. On the right hand side, we have a 5 plus 2 mu. Remember that mu is equals to 1, so it's also equals to 7. Alright, since left hand side is equals to right hand side, right? It shows that when mu is equals to 1 and lambda is equals to negative 1, the two lines do intersect. Okay, the two lines actually intersect. Alright, and what are the particular point which they intersect? So all we need to do is we just substitute back. Lambda equals to 1, negative 1 or mu equals 1. So suppose we to use this. Alright, very quickly you can see that the point of intersection is just 5, 2, 0. Mu is equals to 1, so you have 1, 2, 2, negative 1. So the point of intersection is 5, 1, 2, so you have 7, 2, 4, and negative 1. 7, 4, negative 1. Right? And you can see that 7, 4, negative 1 is the point of intersection. How to get that? Now you just need to sub lambda equals negative 1 or mu equals 1 into any of the two equations. Right? And are not, since they intersect, they are not skew lines. Okay? And how about for 3b? Okay, for 3b,